You know, we are constantly getting hit with numbers, charts, and stats that are all trying to convince us of something. And they seem so objective, right? But as that famous saying goes, there are lies, damn lies, and statistics. So in this explainer, we're going to pull back the curtain and see how numbers, even though they're powerful, can be incredibly misleading.
I love this quote from the economist Ronald Coase. It really sets the stage perfectly. What he's saying is that data can be manipulated, it can be twisted, and it can be framed to support just about any argument you want. Which, leads us to the real question.
It is so easy to see a statistic and just take it as fact. But if you don't have the right tools to question what you're looking at, you're at risk of being misled. So let's build that toolkit. We're going to start with a really common mistake that people make when it comes to chance. Han Solo's famous line, "Never tell me the odds," it just perfectly captures this common fallacy. It's this idea that somehow your belief or your luck can bend the rules of the universe. And this really breaks it down, doesn't it? On one side, you have belief, what the source material actually calls the Tinkerbell effect. If you believe in it hard enough, it'll be real. But on the other side, you have the cold, hard reality of probability. It's not based on feelings, it's just based on math. The key thing to remember here is that probability is really just counting. That's it. If you want to find the probability of drawing a red card from a deck, you just count the red cards and divide by the total number of cards. It's as simple as that. But this simple idea leads to another pretty common misunderstanding. Oh man, people fall into this trap all the time. They'll say something like, well, either a UFO is going to land in New York City today or it won't, so that's a 50-50 chance, right? Wrong. So wrong. Just because there are two possible outcomes doesn't mean they're equally likely to happen. And this chart shows you why. I mean, sure, it can either rain or not rain in any of these three cities, but is the probability 50-50 everywhere? Of course not. Look at Jeddah. It rains about 6 days a year. But in Quibdo, it's over 300. Probability isn't about feelings. It's based on real-world data. All right, next up, context. A big, scary number can feel incredibly important, but I'm telling you, without context, it's often totally meaningless. Numbers do not speak for themselves. So take a number like this, 80,000 cyber attacks per day. That sounds terrifying, doesn't it? It's a number that's designed to make you sit up and pay attention. But what does it really tell us? Is that a lot, a little? Is it more than yesterday or less? Without more information, 80,000 is just a number floating in a void, and it's designed to scare you, not to inform you. This is where context, or what mathematicians call the denominator, is so important. Think about it. If a bank has 2 compromised accounts, that's a total catastrophe if they only have 2 customers. But if they have 10,000 customers, well, it's a completely different story. The number of incidents is the same, but the context changes everything. So here's your toolkit. The next time you see a statistic, ask these questions. Where did the data come from? How big was the sample size? And, this is a big one, how are they defining their terms? What do they even mean by malicious? Without these answers, a statistic is really just an opinion with a number attached to it. Okay, this is one of the biggest statistical traps out there. When we see 2 things happening at the same time, our brains desperately want to connect them. We want to say one caused the other. But that is a huge, huge mistake. So take a look at this chart. The number of computer science degrees awarded is going up. And hey, so is the amount of malware in the world. See how the lines follow a pretty similar pattern? That means they're correlated, and our brains immediately jump to a conclusion. Of course not, that's completely absurd, right? But if you assume that correlation equals causation, you can end up with some pretty ridiculous conclusions. The correlation is just a statistical coincidence. It doesn't prove any real-world connection. Oh, it gets even better. These are real, documented correlations. Did a lack of pirates on the high seas cause global warming? Do Nicolas Cage movies somehow lead to people drowning in pools? No. It just goes to show you can find a statistical relationship between almost any 2 things. That doesn't mean they're connected in any meaningful way. So how does all of this connect to today's technology? Well, there's this kind of myth that AI and machine learning are basically magic. But at their core, they're just really complex statistical systems, and they're subject to all the same flaws we've been talking about. Okay, so any system that has to classify things, like an AI malware detector, can make 2 kinds of mistakes. A false positive is when it blocks something that's totally safe, and a false negative is when it misses something dangerous and lets it through.
The crucial point here is that there's always a trade-off. You can't completely get rid of both types of errors. And this is how we actually measure that performance. It's called a confusion matrix, and you can think of it like a scorecard for the AI. It shows us exactly what the model got right, the true positives and true negatives, and more importantly, what it got wrong, those false positives and false negatives. So let's look at this in action. A vendor might come to you and boast that their model is 96% accurate, and that sounds amazing, right? But when you actually look at the confusion matrix, you see the full story. In this case, 96% accuracy still means 500 threats were completely missed, those are the false negatives, and 300 perfectly safe IPs were blocked, the false positives. That big flashy number hides a much more complicated reality. This gets at the myth of the magic black box, this idea that we can just shovel data into one side and get perfect, flawless answers out the other. But it's not magic. It's just math and statistics, and it's all running on data that was provided by humans. Which brings us to probably the most important rule of all: garbage in, garbage out. An AI is only as smart as the data it's trained on. So if your training data is biased, your AI is going to be biased. Simple as that. It can only learn from the examples that it's given. So if there's one thing to take away from all this, it's this. A number you see on a screen might look like a cold, hard fact, but it's not. It is an interpretation of data. Data that was collected, analyzed, and presented by people, with all of our human biases and blind spots baked right in. We've given you the toolkit now. You know to ask for context, you know to question the source, and to be really skeptical of correlations. So the next time a number tries to persuade you, don't just accept it. Be curious, be critical, and ask the right questions. Thanks for watching.